Hello everyone. Let us start with the new program, that is the measurement of the distance using the ultrasonic sensor in the Blynk platform. Now let us enter the program. Okay, now this is the program for the measurement of the distance using the ultrasonic sensor here. Now we will create the macros in the Blynk platform. For that, go to the Google Blynk. Sign up. Now enter into the developer zone. New template. Enter the name here. I will enter as ultrasonic. Select the hardware ESP8266. Description here, distance measurement. Done. Now save this. Now go to the data stream here. Enter into edit mode. New data stream. Select the virtual pin. And the name here, give as the distance. Pin is V0 here, and the type, distance type is, it is the double here. And here minimum distance is 0 and maximum I'll give as 400. Now create it. Save this data stream. Now the data stream is saved here. Enter on the web dashboard. Again edit mode. Select a widget from the widget box here. For the distance measurement, we'll go for the gauge here. Drag here and place it. Now click on the settings. The title is gauge and the data stream is already created distance here. And the color also, if you want, you can change here. Based on the minimum and maximum value, the color will change this here. And the minimum is 0 and the maximum is 400 we have given. Now save it. Save once again. Now enter into the devices. New device. From the template, choose the template here. That is the ultrasonic. Create. Now the macro codes are generated here for this particular project. Now click on this, it will copy. As you know, code copy to the clipboard here. Once you click here, now enter this code in the program. Once again, go to the program. delete these old macro codes here and paste the new. Now the macro codes are added here. Save it, and also the Wi-Fi name and the password you should enter correctly. After this, save it. Select the location here. Save the program as ultrasonic one. I'll give. Save it. Now program is saved. Now we'll see how the program works here. Here these are the Blynk template ID, that is we are defining the unique ID, that is the template ID here. Next is the Blynk template name, and afterwards it is the token here. That is this is the authentication token provided by the Blynk to link your hardware to the Blynk app here. This is the token provided by the app here, and this is the name of the template, and this is the ID, template ID. This first we have to define in the, these are the macros here, and afterwards the libraries which we are including here is the, that is ESP8266 Wi-Fi.h. This library allows to connect the board to the Wi-Fi network here, and afterwards this Blynk simple ESP8266.h. This library facilitates the communication of this board and the Blynk cloud service here. Therefore, these two libraries should be included. And after this, Wi-Fi and the Blynk credentials here. Here we'll be having the first array here. This array will holds the token here, authentication token, and the second array will, that is AUTH, that will holds the authentication token, and SSID array will holds the Wi-Fi's name here, and this PASS, this array will holds the password of the Wi-Fi. Next, it will be the pins here where we are connecting. We are connecting trigger pin to the pin number D5 here, and echo pin to the pin number D6 of the 8266 board here. Trigger pin of the ultrasonic sensor, that is given to the D5. Echo pins is the D6 here. After this, here the variables here, that is the time 1 and the distance. These are the variables. This time 1 will holds the time duration here, that is the stores the time taken by the ultrasonic pulse to travel to the object and again come back. That is the two-way journey's time is it is saved in the time 1 here. And distance, this is the variable will store the calculated distance based on the time measurement here. The distance is stored in there in the variable distance. Now the function here, that is the void setup function. Here the trigger, it is set as the output here, and the echo, it is set as the input here. This pin will receive the reflected ultrasonic pulse here, and this will be send the ultrasonic pulses. Output, the trigger pin is sending the ultrasonic pulses, and the echo pin will receiving the echo pulses here. Therefore, this is the input pin and this is the output pin here. And here we'll be having the serial begin. This is 9600. This is the baud rate here for the display of the on the serial monitor here. This one you have set here. Next again this one Blynk begin this particular authentication code, Wi-Fi name and the password. These are the for the connect the ESP8266 to the Blynk cloud here. Next, this is the program here. First, at this start of the program, first we are given the low signal is transmitted to the trigger here. This trigger pin sets the low to the for the 2 microseconds. That is for the 2 microseconds. The trigger, that pin is set to the low, and when this 2 microsecond ends here, again it is given to the high signal to the trigger. It will ensure that the clean high signal is given to the trigger here. Next is the again the particular delay here 10 microsecond. If you observe here after 10 microsecond again the trigger is given to the low here. Up to 10 microsecond the trigger is high and after that it is given to the low signal here. Next, that is the time 1 pulse 1 here. That is, if you observe here in the time 1 the pulse input, that is the echo signal, that high signal is stored here. That is the time 1. Function measures the time in microseconds for the echo pin to go high. That is, when the pulse returns, this time is stored in the time 1 variable here. That is for how much duration the echo signal is high. That time duration is stored in the time 1 here. Now the distance we can calculate, that is distance equal to time into 0.034 divided by 2. The distance is calculated using the formula distance is equal to time into speed of the sound divided by 2. Here usually the speed of the sound approximately it is 0.034 centimeter per microsecond, and the divide by 2 accounts for the pulse is traveling to the object and back. There is a true way journey of the pulse here. Therefore divided by 2. If you apply this formula, we will get the actual distance here from the object. Therefore, the time, how much it is taking to pulse to go from the transmitter to the receiver. Again, echo pulse is coming from the object to the receiver section here. That two-way journey's time duration into 0.034, that is the speed of the sound divided by 2 here. Now in the serial port, we can display the distance in centimeter and also the distance serial print, that is the distance we can display parallel on the serial port here. And we are given the delay as the 1000 milliseconds, that is 1 second. After each, to change each value after 1 second it will changes the value here. Now the Blynk virtual V0, we have selected the pin as the V0, virtual pin as the V0 here. Therefore the distance is sent to the Blynk cap using the virtual pin V0, where it can be displayed or logged here. Now to operate continuously here, keep the connection to the Blynk cloud service. The Blynk run app is used here. That is a Blynk run command, such that continuously it is connected to the cloud here. This is the working of the program here. Next, if you do the connections here, just this is the ultrasonic sensor here. It is having transmitter and the receiver. 3 or 4 pins, VCC, trigger, echo and the ground pins here. The transmitter will radiate the ultrasonic signals. It will strike the object and the echo signals are coming back towards the receiver here. Now this time duration is measured and using that time duration the distance is calculated here. And for the connection here, the VCC it is given to the here 3.3 volt and ground pin is connected to the ground pin of this 8266 and trigger is connected to the D5 pin here, D5, and the echo is connected to the D6 here, D6 pin, D5 and the D6. That is the connection here. Now if you observe how it works here, that is for the 10 milliseconds, the trigger is that input, for that input high signal is applied here. For this trigger input high signal is applied for the 10 milliseconds here. Once the high signal ends here, the trigger signal will start generating the ultrasonic signals, usually up to the 8 pulses it will generate here. Now they will travel towards the target or the object here, and when these signals will end here, at that point the echo signal will be high, and after that when the echo point will be, that signal is set to high, and when the echo signal receives the high signal, that echo point will be set to low. Means this duration will indicate the width of the represent the distance here actually. Now this is the waveform representing the working here. First, for the 10 milliseconds of the duration pulse is applied to the trigger input. After once this 10 millisecond ends, that trigger point will generate the ultrasonic pulses here, and those are traveling from transmitter to the receiver here, these pulses. Now once these pulses ends here, at that point this receiver's echo point that is made high, and when this echo signals are coming back, and when these last echo signal will reach this here, again it is made to 0 here. Therefore this distance is the actual distance. Now this is the working here and the connection. Now we will save the program. Already program is saved. Compile the program. Now the compiling is done. Now we'll upload the program here. Upload it. Now as we can see, the uploading is completed. Now if you observe now you can see the distance is measuring here. The distance it is giving. Now let us see the settings in the mobile here. Open the Blynk app. Open the template here. Go to the settings. Take new widget. Select it as a gauge here. Click on the gauge. Select the data stream here. You can change the color also here. Now this is the settings in the mobile. Now we'll observe the output here after the connection. Now after the connection here, we can see the output on the mobile as well as on the laptop here. As the object is moving away, the distance is increasing here. Therefore, the distance is measured. Thank you.